Hello friends, JBrains again, coming at you with some more fundamentals of test-driven development, evolutionary design, and high discipline programming. In our last episode, we finished off with me promising to tell you why I call this architecture without trying. And now that we take a look at our sail class, I want to ask you if anything looks familiar. So if you want to pause, think about it for a while, or if you're already screaming the correct answer, or at least what you think is the correct answer at the screen, then good for you. Maybe if we draw a little bit of a diagram, it might help. So let's take a look over here. We have our sail class, and our sail has a reference to a map that represents that stores the prices by barcode, and it also has a reference to a display. Does this structure look familiar to you? This shape of the class diagram? No? Well, what happens if I add a few letters to this diagram? Over here, I'll add an M. Down here, I'll add a V. And up over here, I'll add a C. That's right, Model View Controller. By merely focusing on test-driven development and removing duplication, in other words, only writing production code with a failing test and removing duplication, the structure of Model View Controller has emerged for this problem. And I believe this is a problem, one of many, and I'm sure it probably occurred to you, that this is the kind of problem that wants to be solved with Model View Controller. There are some problems that simply want to be solved that way. This is one of the basic architecture patterns that we've learned. In fact, we've probably taken for granted, and I find it really comforting to see how to, for lack of a better way of putting it, justify its existence by relying on basic principles of design. Don't write code without a failing test. Remove duplication. Now, if we go back over to the 4 elements of simple design, pass the tests, remove duplication, improve clarity, and make the code smaller. And I believe that most of clarity problems in code have to do with bad names. And so I actually like to reduce that list to 2 basic rules: remove duplication and improve names. And it turns out there's this amazing little correlation between these 2 design principles and the emergence of Model View Controller in our code in this example. Now we can see that by focusing on removing duplication, the structure of Model View Controller has emerged. Sail is our controller class, the map is our model, the display is our view class. But even though we have the structure of Model View Controller, which I think we generally take to be a good sign, a sign of at least reasonably good design, let's say a sign of not obviously bad design, there are still some design problems in here, and they have to do with the distribution of responsibilities. Let's take a look up here in our test, which is where we create our model. Since our model right now is just a naked built-in data structure, we don't have a class for it yet, so the only place that we can really look at it is where we instantiate it. And so in our test here, we see that the prices by barcode model has a serious design flaw, and that is that these prices are already formatted. Formatting a price definitely sounds like a view responsibility, not a model responsibility, so why is it in the model? Or worse, why is it in the model's client? A thing that we haven't even identified yet. So this responsibility is definitely in the wrong place. Similarly, if we look inside the controller back on barcode, we have another view responsibility in the wrong place. And that's in 2 places here where we are formatting messages. And formatting messages certainly sounds like a view responsibility and not a controller responsibility. So here, in our Model View Controller structure, which we like and which looks good, and the diagram is pretty and it's a nice directed acyclic graph, even if it's a relatively small one. But the problem is that up in the sail, we have a misplaced responsibility of formatting messages that belongs in the view. And in our map, in our model, we have a misplaced responsibility of formatting prices, and that belongs in the view. And it'd be nice if there was some natural force, some mechanical design principle or guideline or rule we could follow that would encourage us to move these responsibilities into the view. It's one thing to have an intuitive sense of where code should be, but if I can also follow a design rule that encourages that code to move to the place where I believe it should go, then it's like the 2 sides of my brain are in agreement with each other, and that makes me feel good. That my intuitive side and my mechanical rule following side, when they agree, that gives me hope. That gives me encouragement. That makes me believe that the idea I have is a good one. And as luck would have it, I've noticed that focusing on removing duplication helps the model view controller structure to emerge, and focusing on improving names and improving clarity in the code helps move the responsibilities to the appropriate place. And let's see an example of how that works. Let's take a look on barcode here. Now, notice that we have a naming problem. It's a bit of a weird naming problem, but it's a naming problem nonetheless. That's the way I like to think of it. And that is that I'm using display set text to do three different things. I'd like to give these three things a name. Whenever I use the same method to do multiple different things, that tells me that I'm using too low level an API. And extracting some methods is a good way to raise the level of abstraction and to clarify what it is that's going on. You could think of this as a naming problem in that I'm forcing the reader to use vocabulary at a very low level when I would really prefer to express ideas at a higher level of abstraction. So for example, what does this line of code do? Well, this line of code displays empty barcode message. Well, then let's call it that. Display empty barcode message. All we're doing so far is using the composed method pattern that we learned from Kent Beck, the idea of just extracting methods in order to make the code easier to read at a higher level. We want the code to tell a story. This is a way of improving clarity in the code. Well, we can do the same thing down here. This method is display product not found message. And this bit of code in here is displaying price. Now, when I extract these methods, I'll run the tests. They all pass. So let's check that in. So introduced methods to clarify the intent of some code. But there's something strange happened here. Notice that display price takes a barcode as a parameter, and that just sounds wrong. That can't be right. Let me put it that way. Display price should probably take a price, not a barcode. That tells me that there's a single responsibility problem in here already. So let's take a look inside display price, and sure enough, there's the barcode, but we're doing two things at once. We're displaying the price, and we're getting the barcode. So this, again, I can look at this as a naming problem. We have a name that's correct, but incomplete, imprecise. Remember the difference between precision and accuracy. Accuracy has to do with how close you are to the correct answer, and precision has to do with how many decimal places or how finely you're measuring. So if I say pi is 3.14, I'm accurate but not very precise. If I say pi is 2.313412641334122, I'm very precise but not particularly accurate. This method call, the name of this method, display price, is accurate but not very precise. It doesn't include everything that we do. We can rename it to something much more precise. So let me do that. Find price, then display price. That describes what this method does. It finds the price for a barcode, then displays the price. And there's something in this name that gives me a clue what to do next. The existence of a conjunction, and, or, if, but, then, in a method name, in a class name, in a variable name, tells me that I've got multiple responsibilities in one place, and maybe I should split them up. And in fact, that combined with the fact that display price was taking a barcode tells me I do want to split this behavior up. So I can introduce a variable here for the price. Now, price is not something that normally should be text, so I'm going to name this price as text, just to emphasize the fact that it's text and not just price the way you would think to normally store it, either as a number or as a whole value class. The mere fact that I would name a variable price as text indicates that I'm storing the value as a data type or in a format other than the one that I would normally choose to store it in. And in this case, since it says text, that's a pretty clear sign of primitive obsession. Text is maybe the most primitive of all data types. But now we have find price and display price. Well, let's extract those methods. So this is find price, and this is display price. No. In fact, it looks like yes, so now we have display price that takes a price instead of display price that takes a barcode. So the naming for display price now makes more sense. Notice also that we have display.setText, price as text. Text goes with text. Find price then display price probably isn't pulling its weight anymore. So I can inline this variable, and then I can inline this method. And now if we take a look back up on barcode, we see something that makes a little bit more sense. We have find price then display the result. And I think here, let's run the test to make sure they pass. Here we're coming much closer to being able to tell the story. We're clarifying the intent of the code much better. So introduced more methods to clarify intent. Now we have another kind of naming problem, which has to do with a little bit with the single responsibility principle. And that is what happens when code at multiple levels of abstraction are in the same place at the same time. Now, it's one thing to force the reader to use a low-level vocabulary to represent a high-level idea, right? Think about design patterns for a moment. In fact, we don't even have to go there. Just think about nouns. You know, I could refer to the seating apparatus with a 5-spoke wheeled base on which I'm seated at the moment, or I could talk about my chair. I shouldn't have to use that long description every time I want to refer to a chair, especially if what I want to refer to is the general notion of a chair and not any particular chair I happen to be sitting in. That's the idea of abstraction in language. That's why we have the word chair instead of having to describe what a typical chair looks like every time we want to refer to a chair. But the code that we had in onBarcode was the equivalent of forcing me to refer to the description of a chair instead of using the word chair. So I raised the level of abstraction by extracting some methods, and the names of the methods did a better job of clarifying the intent of the underlying code. But now I have this code right here, prices by barcode contains key, that remains at a lower level of abstraction than the rest. And when we mix levels of abstraction, that's jarring to the reader. It's difficult to read. It would be easier if we at least made all the levels of abstraction in the code the same. So we could extract another method here called hasBarcode. Now another way we can go here is actually rearrange the code. If we don't like that, we can actually rearrange the code and we can find the price, and if the price is null, then we know we didn't find the price, and if it's not null, we knew we found it. And for reasons that I wish I could explain, it turns out that code's actually nicer. So I'm going to make that change now. So let's see. Invert if condition. And I'm going to take this here and introduce a variable for the price as text. And I'm actually going to move this up here. Oops. And I'm going to change this to if price as text equals null. Let's run the test and make sure it passes. Excellent. All right. So removed some low-level code. And now I think this reads pretty well. Find the price, and if I didn't get one, display product not found. If I did get one, display the price. That code, I think, speaks about as clearly as it can, and it speaks at a relatively high level. Up here we even have, if the barcode is empty, then display empty barcode message. I could replace this function here, this expression here, with barcode is empty, but it doesn't seem to me to actually describe what's going on any better. And that's a bit of a judgment call. I would say if you're not 100% sure, err on the side of extracting another method. You can always inline it later. Now let's take a look at the methods that we've extracted, and let's see if they have anything particular in common. Well, one thing that I notice is that these three methods here, all the display methods only talk to the display object, whereas find price only talks to the prices by barcode object. That tells me that find price is really a model method. It wants to be on the model. And these display methods really want to be on the display. This is something called feature envy. Feature envy is a code smell that I learned from Martin Fowler's original book, Refactoring, Improving the Design of Existing Code. And feature envy describes when a block of code wants to be on another object. Now, if you're working in a functional language, then instead of object, think module. So if you have a function in module A, and it seems to be talking only to a bunch of other functions in module B, and it's not a client of module B in general, if it's not talking to any other parts of module A, then maybe it should be in module B. Well, this is the same thing. Display price, display product not found message, and display empty barcode message only talk to the display and local variables and function parameters and not to any other aspect of sale. So I think these methods make more sense on display. The same for find price. Find price talks to the model and to the function parameter, but not to any other aspect of sale. It doesn't talk to the display. Only on barcode actually talks to the display and the model both. So on barcode, it certainly makes sense to stay in sale, but these little methods can probably go. So let's move them. Let's move this to the display, and let's make it public. Let's move this to the display and make it public. And let's move this to the display and make it public. I make these methods public right away simply because I don't like to use the protected and package level visibility constraints except when I'm working with legacy code. Public and private are confusing enough. I like to keep it to simply public and private. So let's run the tests to make sure they still pass. And then let's take a look at what we've done. What we've done now is moved some methods onto the display. Those methods look pretty straightforward. And what we've done is we've magically moved, not magically, but somewhat magically, by improving the level of abstraction in the code, by introducing methods, and then by noticing that that highlighted feature envy, we've taken those methods and moved them to the more appropriate place. Now the view responsibilities for displaying a price, displaying messages have moved onto the view. One down, two to go. So let's go back where we were. Find price is a little bit more problematic because we can't put this method on map. Map is a built-in class in Java, and unfortunately in Java we can't add methods to built-in classes, or we can't reopen a class that we don't own and add code to it. Now, even if I were working in Ruby or Python where I could do this, I wouldn't. Find price definitely doesn't sound like the kind of method that belongs on a map. We might use a map to find a price, but that doesn't mean that all maps find prices. In fact, most maps have nothing to do with prices at all. It definitely highlights a bit of primitive obsession. The idea here is that sale, instead of referring to prices by barcode, should probably be referring to an object that encapsulates that naked data structure and provides a place for code to go. I can introduce this by introducing a parameter object. And that parameter object will be called catalog. And the only parameter on the catalog is this map. So the catalog is the thing that maps barcodes to prices. I think that sounds like a pretty reasonable name. So let's create, let's create an inner class called catalog. I feel lucky, why not? So what we have in here so far is we've just changed the parameters to the constructor. Let's just see if by chance if everything still passes. It appears to. Let's take a look at their tests and see what we ended up with. Now we have new sale.catalog, now we have new sale.catalog. I didn't want that to be an inner class of sale. I want it to be the inner class of the test. So I'll redo that. That's fine. Let me just go to catalog here and let's move this class to the upper level. That's what I wanted. Okay. Looks like IDEA just refactored a little differently than I expected. Let's make sure the tests still pass. IDEA confused me for a moment by making the catalog part of sale instead of part of the test case class, but I actually really appreciate what IDEA tried to do for me. It created the class in the narrowest scope possible, which generally is the safest decision to make. It's much safer to take something in a narrow scope and make it more widely visible than it is to start making it more widely visible and then try to narrow its scope later. It seems like the vast majority of work I have to do with legacy code is to take stuff at too wide or too visible a scope and put it in the narrow scope it should have been in the first place. Excellent. Now we have this get prices by barcode, which I'd prefer not to use. Let's see where that's being used here. That's here. So the old code stores prices by barcode, but I'd rather have it just talk to the catalog. Well, now we have a place for our find price method to go. So let's move this. We want to move it on to catalog, but we're not storing catalog yet. So let's store it. And now we have a place for this to go. So let's take a look at the code here in sale. Now we have catalog.findPrice. Now findPrice needs this as a parameter, but it turns out that we don't actually have to use the sale here. Why? Because sales prices by barcode is the same as catalogs prices by barcode. So this should also work. Which means now we can remove sale. All right, now back here, nobody's using the prices by barcode field, so we can remove it. And that means nobody's using the get prices by barcode method, so we can remove it. Let's make sure all the tests still pass. And now what we've done is we've successfully moved find price onto a new catalog object. So fixed feature NV in sale find price. And once again, we have magically, well not magically, but mechanically moved the formatting responsibility. Well, we haven't quite moved the formatting responsibility yet. That's coming up. But we've moved catalog responsibilities out of the controller and at least into its own model. And now it would be relatively easy to replace this with a price object, which we can then use to display text in the display. I'm going to leave that as an exercise to you. You can give that a shot if you like. But what I really like now is the fact that our catalog is very simple. We just have create a catalog from a lookup table and we can find the price. And if we take a look in our display class, notice, by the way, that now the only people who use set text are other methods on display. And we can test that by changing this to private. And if the tests still pass, excellent. Well, that means we don't need this method anymore. Let's inline it. Now you can decide for yourself whether you like this or you prefer using set text as a private method. If you want to leave set text in there as a private method, you're not going to hurt my feelings. I'm happy with that. But what it means is now the outside world can't just set whatever text they want. This is much closer to a well-designed object. The methods for changing the state of the display have a business concept to them. They're business level abstractions. Display a price, display product not found, display empty barcode message. The only thing that I'd want to do now is to change display price so that instead of displaying text, it's actually displaying a price object. And as I said, that's a refactoring that you can introduce later. Of course, now the method display price has a pretty serious design problem. Although the name says display price, the parameter is of type string, which means it can be any arbitrary text. The word price in there is entirely decorative at this point. That means that before long, some programmer at some point is going to pass in whatever text they feel like that has nothing to do with the price. And so we probably want to deal with that sooner rather than later.
This is another example of the insidious nature of primitive obsession.
So, by focusing on removing duplication, the structure of model view controller emerged. And then by focusing on improving names and improving clarity in the code, the responsibility started to move towards more appropriate places. And although we haven't got rid of all the responsibility misplacements, if you will, that's a relatively easy step to finish. I won't let you watch me doing that now. We'll save that for a future episode. Thanks again for watching. Hope to talk to you soon, and happy coding.